It is that time of year, early April. It is time for my way too early predictions for next winter, which as of last year became actually my most popular video on this YouTube channel. So I'm expanding it this year to a full prediction slate in terms of what I believe I'm able to predict. I'm meteorologist Hans Leach, bringing you this early look at what's coming up 8 to 11 months away. Here is my usual disclaimer. This is long range forecast intended to provide a general sense of what may happen in the coming months. It is not this is for sure happening, nor is an excuse not to be prepared for any extreme weather. Also, because November is still 7 months out, the error will be higher than the respective October and December forecasts. Right, now that that's out of the way, my methodology, I use an analog year approach, adjustments made as necessary using ENSO via the Oceanic Nino Index and confirming it using the Southern Oscillation Index. I also use the Pacific Decadal Oscillation. The Atlantic Multi-Decadal Oscillations dataset is still down, so that's still on the back burner only. The QBO, I decided I'm only going to use for the October and December forecasts only, mainly to help determine the top analog years. I do use the current sunspot counts, and then I will weight the analog years equally for this forecast and then just use my forecast parameters out of those analog years. That's different than my October and December forecast where I do not weight them equally, and that brings me my top analog years, and even those aren't even weighted equally either, which is why you see the weighted formulas when you see the October and December videos. Adjustments to analog years can be made using statistical analysis if there's a statistically likely or unlikely chance of something occurring. Analogs will be adjusted unless if there's a clear trend in the analog years showing the opposite. I will also use general trends based on the previous season when appropriate. Snow prior to the 1970s have been adjusted to a 4.3-inch average per winter on analogs. Temperature departures have been adjusted to the averages at the time of which they occurred. So, for example, if I'm using analog year 1924 to 25, I'm going to be using the averages that were in place then, not the current 1991 to 2020 averages. All forecasts will cover what has happened in one out of every 3 winters at the Portland airport. So on to our data and oscillations. First off, I'm going to take a look at the ENSO outlooks. First up, the US outlook. One thing I did take a note of compared to last year is that I took a look at my previous winter weather outlooks and compare that to the actual ENSO outlooks put out by NOAA and what actually happened. And NOAA actually has a cold bias of almost half a degree Celsius. It came out to be a 4/10 of a degree Celsius. Compare that to the Australian model, which out of the 5 years I've been doing this, has come out to be right on the mark or a tenth of a degree off each year using their formula, which takes the global model average. Now, the Australian model has changed its methodology this year, so we'll see how well it does. Sidebar ending, the US outlook, not factoring in the cold bias, shows that we'll be on the cold side of ENSO neutral pretty much throughout the summer, and it being relatively stable going towards next winter. The CFS is drunk again, saying that we're going to have a quick dip next month before we're climbing back up. Though I will say observations are pretty much right at neutral right now, so who knows? Maybe that actually will verify. If you factor in the typical cool bias, that will put us probably right in this zero point 0.2 to zero point 0.3 frame, which is the warm side of neutral. Taking a look at Australia's new method, which is just using their own in-house model rather than the global average and taking it from there. They're showing it a little bit warmer compared to NOAA's models, and as a result, showing on the side of El Nino. They also use a different definition for El Nino, so they only need 1 month of 0.8 of a degree Celsius or warmer compared to NOAA's definition of 5 consecutive 3-month averages of half a degree or higher in one direction or the other for El Nino and La Nina, respectively. They don't really show a chance of La Nina. They show about a 1 in 3 chance of El Nino as we go into the fall. Though it does look to be decreasing in odds as we actually go into fall. For anyone who wants a windstorm, you want it to be ENSO neutral. If you go further into the El Nino or La Nina categories, the less likely you are to have a major windstorm. Though many years with neutral don't have any sort of windstorms. Southern Oscillation Index the last 2.5 years, this is kind of the one thing that deviates from the we're going to be neutral to a positive tilt after factoring NOAA's cold bias. And this shows the Southern Oscillation Index is pretty firmly in the positive phase right now, and that actually would show La Nina-like conditions. Now, the Southern Oscillation Index is a little bit more volatile, so we'll see if this holds going into September and October. So I will punt this portion of the forecast until those and weight it a little bit less than I normally would. The Pacific Decadal Oscillation still firmly in the negative phase. The last time any month showed positive was June of 2020. Though I will say we have come up about 2 points since the all-time record low value in October of 2024, where the anomaly was minus 3.8. We're sitting at about minus 1.2 right now. Sunspot count, the Space Weather Prediction Center shows that we have hit the solar maximum this last year and we are starting our decline, though I won't be surprised if we stay relatively stable the next year or two. One thing to note is that for anyone who wants a La Nina, the time period immediately following the solar maximum for the year to 2 years afterwards is the least favorable time for La Ninas. In fact, you have to go back to the 1970 cycle to find a La Nina coming out of the solar maximum. And I believe that was still, well, 2 years afterwards because it was more of a plateau type solar maximum versus this is being predicted more of a traditional peak solar maximum, more similar to what happened in 2013 to 14. So, with all that being said, let's move on to our analog years and other bits of data. So, for my analog years, I have chosen 25 years that I think will be condition-wise pretty close to what will happen next year. One thing to note is that these years are all ENSO neutral years or in the weak or moderate El Nino categories that are following either an ENSO neutral year or a weak slash low end of moderate La Nina year. So I do believe the year before is important to determining the year after. So that narrows me down to the years here. Also, as a side note, because the Portland airport data only goes back to 1940, before that, I use downtown Portland data, and to convert the rainfall totals over to the Portland airport totals, I multiply that by the anomaly difference, which is about 85% or so. Second thing to note is that there was 1 year from my top analog years that is carrying over to this year. The rest of them have not. That's 1887 to 88. Side note, 1886 to 87 was the top analog year that ended up being the closest to what happened this winter. So will that be the same? We'll find out in about 7 months or so. One thing to note as well, why am I not putting any strong La Ninas in here? There has never been a strong El Nino that occurred after the previous strong El Nino. And that didn't matter whether there was a gap in El Nino years or not. So I'm pretty confident we will not have a strong El Nino this year from that fact alone. So for the water year rainfall total at PDX, there's a big cluster right around the average of 37 inches to down to about 29 inches or so. The median turned out to be about 32.73 as the biggest cluster was right in this 32 to 34 inch area. For the temperature departure from average, also at PDX, the median turned out to be about 1600ths of a degree above average, but there was a lot of disagreement. For the lowest wintertime temperatures at PDX, the median turned out to be 21 degrees, with there also being no clear signs of clustering. Though I will note in the extreme side, we did have the winter of 1887 to 88 on here, which again, that's the year following my one of my top analogs of 1886 to 87. That had downtown Portland's all-time coldest temperature of -2 degrees. The adjusted snowfall at PDX median turned out to be about 2.1 inches. Only 2 years exceeded 8 inches. And then just for the record, 8 is about the 3/4 mark. So that means only 1 in 4 winters sees more than that. If we were just blanking this out and say what would be the equivalent of 1 in 4, I would want to see about 6 to 7 at 8 inches or higher for comparison. Now, on to our historically significant trends. There's been 10 consecutive winters that have had measurable snowfall. This is a record high. Chance of a 11th occurring is 2.7%. That's ignoring the analog years just for the record. Only 3 winters have produced a temperature under 20 degrees with less than an inch and a half of snow. All 3 had 0 snowfall. There's also been 5 winters in a row where the total days with snow on the ground have been above the median, which is 1.5 days. This is also a record high and breaks a record from the 1950s. Chance of a sixth occurring is down to 1.5%. So, right there, just with those two alone, and combine that with the analog years already being a little bit pessimistic on our snow chances, increases my confidence that we will not have a pretty active winter when it comes to the snowfall department. There's also been no deep Arctic blast for 11 winters in a row. This is also a record high. A deep Arctic blast is defined as the 850 millibar temperature, which is about 4,000 feet, measured over Salem, where we have our weather balloon launches. That is at -12 degrees Celsius or lower. That is the temperature required to keep the entire air column at freezing if you descend that air parcel in a perfectly dry environment with no other processes. If you warm that up to -11, it'll go above freezing right before it hits the surface. Chance of a 12th occurring, I haven't actually calculated this because I actually uncovered some new data that's actually going to help me go further back when it comes to my Arctic Blast worksheet that I have on the full report when that is released in October. However, I do know it is less than 10%. That being said, I also know it is not likely to be lower than the consecutive winners chance, as the original percentage chance I calculated was about 6% before this new data, which will likely raise it up a little bit. So, as a result, this is overridden by the snowfall streak, and also the analog years weren't super confident in showing an Arctic blast. So moving on to our predictions, and we will start with the basics. Rainfall, I'm predicting a near average winter, with Portland seeing about 30 to 38 inches compared to a long-term average of about 37. Long-term median's actually a little bit lower, or being about 35 inches, which is closer to the middle of this forecast. South Valley, anywhere from about 34 to 43 inches. Temperature departure from normal, near to a little bit above average, but I'm not anticipating a crazy warm winter, just within about 2.5 degrees of average in the positive direction. Windstorm, right now, I'm thinking it'll just be a typical year from about 45 to 55 miles per hour. Side note, this is the first year I'm confident enough to make a windstorm prediction in this way too early video. Lowest temperature, I'm anticipating that to be above 20 degrees this winter. And then most likely to be active too early to call that. I need top analog years to make that prediction. So, mountain snow depth on April 1st, I'm anticipating that to be about 60 to 90% of normal. This is still plenty of snow for the ski resorts, but not as much snow as we've had these last couple of years. And then for valley snowfall, relatively quiet year, anywhere from about 0 to 2.5 inches, with best estimates being 0 inches, regardless of your location in the valley. I actually won't be surprised if this is a winter where we get not even a trace of snowfall. Chance of no snow winter is right around 50%. So that is going to be it for this video. I am also releasing my winter weather verification at the same time of this, so check that out if you want to grade how I did last winter. Spoiler alert, it was my worst one on this YouTube channel. So otherwise, stay safe out there, and until next time, take care.